Hello, everyone. This is now section 4.2. I'm going to continue this section. But before I start again this section, I just want to remind you again about the daily quiz. So again, you have to watch the whole lecture to see if I assign anything for today's lecture or not. And one thing, even though I don't assign anything, when you go in here, like I said, I will be assigning everything here on this, right? Daily work submission. So even though I don't assign anything, let's say for example, this section, if you watch the whole lecture, you'll know it whether I assign or not. But let's say if I don't assign anything, but still you will see a tab here. All right. So if I don't assign anything, you don't have to submit anything. You don't have to submit. But still, I will be creating a tab for the whole section that I will be covering for this semester. So that's why I keep saying you have to watch the whole lecture to know if I assign anything or not. Yeah, if I have a tab here, doesn't mean that I have assigned something. Maybe I will create a tab here, but still I may not assign anything. All right, so anyway, let's start this section. Okay, so here again, well, basically, I'll be doing two examples here, and basically, if you see, we need to find all of these, which we have already done on the previous lecture. So basically, here I will be combining everything. So we need to find all of these with this one function. All right, so probably you'll see something like this in the exam. Or maybe not, or maybe, I don't know right now, but you definitely need to know all of these for the exam purpose, all right? Okay, so now, okay, let's find the critical number first. So, okay, let me do it on the next page. So we know that f of x is x to the power 4 plus 4 times x to the power 3, right? So to find the critical number, we need to find the f prime, right? F prime of x, which is 4x to the power 3 plus 12x square, right? So once you get this now to find the critical number, I have to assume f of x is equals to 0, and then find the value of x from here. So we know f prime of x is this, so 4x cubed plus 12x squared is equals to 0. So from these two, I can factor out, well, from 4 and 12, I can factor out 4. From x cubed and x squared, I can factor out x squared, right? So then the remaining terms are x plus 3. So from here, I can assume either 4x squared is equals to 0. So from here, I'll get x is equals to 0. From here, I get x is equals to -3. All right, so I get 2 points. So these 2 points are still, well, we don't know if these 2 points are a critical number or not. But since this function here is a polynomial function, so the polynomial function, the domain is basically everything. So whenever you deal with the polynomial function, the domain is basically everything, or maybe that means any x values here is going to work. Okay, so so that means we have x is equals to 0, x is equals to 3. So that means these two values are going to work here for this function. So that means I can say these two are critical number. All right. So, and the exam, I might ask, so why these two are critical numbers. So in that case, you have to explain whatever I said right now. All right. So since I said I might focus on conceptual problem. All right. So maybe you saw that in exam 2 as well, that I asked few conceptual problems. So that's why I'm saying you need to understand the concept. All right. Yeah, you can do maybe you can do the mathematical thing. You can solve it, right? But the main thing here is you need to understand the concept. All right, and so once you get the critical number, now the second thing we are looking for was increasing, decreasing intervals, and also local maximum and local minimum. So I can find these three things after taking f prime. And these last two things I can find after f double prime of the second derivative. All right, so now let's find increasing and decreasing intervals. So as we said that, okay, let's make a sign chart here. So let's say -3 is somewhere down here. 0 is somewhere down here. Now I need to take any points on this region and see if we get positive or not. Or if you, let's say, if you pick any points, let's say x is equals to, let's say, -4, then plug this into f prime, right? So when you do that, if you plug in this x is equals to -4 to this f prime, then you will get this part. You can do this on your own. I'm not going to do it. So you're going to get this negative. You get this reason negative. So, and then similarly here, if I pick any point in this region, let's say I can pick x is equals to, it doesn't matter, but you can pick any point in this interval, let's say -1. Again, plug this in to this equation f prime, and then you'll get this positive. Oops. Get this positive. And also if you pick any point on this region, let's say x is equals to, doesn't matter, let's say 4, 5, 1, let's just take 1, you'll get this one positive too. All right, so that means this is negative, so this is decreasing, right? This is increasing. Let me just write I and C, which means increasing, and also this is increasing, right? Okay, now when you see this, well, this one is decreasing, this one is increasing. So if there is a sign change, something like this, then this point, the critical number in between those two is going to be either local maximum or local minimum. But the thing is, here this is negative, so that means if it, well, we said this is decreasing, right? So decreasing means it will be something like this. And after this point, it is increasing, right? After this point, it is increasing, right? So that means this point is local, or well, basically you can say at this point we have local minimum, but we need to find the exact point. All right, you need to write exact local minimum point. Okay, so now since the problem was asking, okay, so we got everything that we need. We were looking for decreasing, increasing intervals. We're looking for local maximum and local minimum, but it looks like we don't have local maximum for this. So we don't have to worry about that because we cannot find local maximum because this is positive, this is positive. So both of these are increasing, and also it is increasing. So you cannot find local maximum for something like this if both of these has either positive or negative. All right. Now, okay, now let's write everything we have. So the decreasing intervals, let me just write D, decreasing intervals. is this, right? Which is negative infinity to negative 3. Increasing interval is negative 3 to 0. And 0 to infinity. So please don't write, since you see this is positive, this is positive, so please don't write just negative 3 to, you may be thinking, okay, why do we have to separate this into two things, or yet like on 2 parentheses? Why can't we just write like this, right? You might say that, but no, you can't do that because the graph, well, even though I said the graph is increasing for both of this, maybe, I don't know exact graph, but maybe it will be increasing and again increasing, something like this. So here it looks like this is concave down, this is concave up. So you cannot just combine these to a single interval, all right? So you can't do that. You have to write 2 separate intervals. Okay, that's not possible. Okay, now after that, the local minimum, we said at negative 3, it's a local minimum. So at x is equals to negative 3, what is f of x, or what is f of negative 3? So if x is negative 3, basically after you find at what point is local minimum or maximum, then I have to take that point and I have to plug in this point to the original equation, our original f function. Okay, so then from here you'll get negative 3 to the power 4 plus 4 to the power negative 3 cubed. And from here you will get negative 27. So that means the local minimum point is negative 3, negative 27. All right. Okay, now after this, we need to find inflection point and concave down and concave up intervals. Okay, so for that, as I said, that we need f double prime for this. But let me write what is f prime first. So f prime is 4x to the power 3 plus 12x squared, right? We got that from the last page, right? We got f prime, or f prime of x. We got it from here. Yeah, we got it from here. Okay, now after this, I can find f double prime of x, which is 12x squared plus 12 plus 2 is 24. So 24x, right? Now for this, again, I have to set this, well, I can set this is equals to 0, and then f double prime is 12x squared plus 24x is equals to 0. So from these two, I can factor out 12 and x. The remaining terms will be x plus 2 is equals to 0. So from here, I can say 12x. I can say either 12x is equals to 0, so x will be 0. And from here, you'll get x is equals to negative 2. Again, we don't know if these two are an inflection point or not. We don't know that, so we need to check that. All right. So the way we check this is we can make a sign chart. So let's say negative 2 is somewhere down here, 0 is somewhere down here. Okay, and after this, you can pick any point in this interval. Let's say if I pick x is equals to -3, and then you can plug this in to this f interval, f double prime of x. So here x is -3, x is -3, and see if you get a positive or negative number. So so I'll just give you what you get here. So you'll get a positive number here, and for this one you'll get well, if I pick, let's say any point, let's say x is equals to -1, then you'll get here a negative number, and here if I pick x is equals to, let's say 1, then you'll get a positive number, right? So now, as we know that if there is a positive, then I did this in yesterday lecture. So if you get positive from the f double prime, then I can say this is concave up, right? Or let me just write, or I can write the whole thing this time, concave up, right? If this is negative, it's concave down. Or let me just write CD, concave down, and plus means again concave up, right? So as we can see here, this and this reason we get positive, and this reason we get negative. So if we have a sign change, something like this, then this partition number is this is an inflection point. And also here we have a negative, you have a positive. So if we have the sign change like this, then this middle partition number is also, so these two are both inflection point. So at this point we have a inflection number. All right, so at this 2 point we have inflection number, so we have to find the inflection, the whole thing in inflection point, the actual point. All right, so first let's write down the concave up and concave down interval. So concave up interval is, well, these two, right? So this one is from -infinity to -2, right? That's one interval. Another one is 0 to +infinity, right? And another one, concave down, or CD, is from -2 to 0, right? And as you said, that the inflection point are these 2 points, right? So now I can find the exact point. So if I say at x is equals to -2, we know that at x is equals to -2 we have inflection point. So if at x is equals to -2, f, the original function f of -2 is equals to, so if you plug this into the original equation, -2, the original equation, which was this function, right? Then you will get -16. That's 1 point, right? So from this one, we can say the inflection point is -2, -16. And at x is equals to 0, again, f of 0 will be, again, from the original equation, from this equation, it will be 0, right? So another inflection point is, so this is inflection point. Let me just write IP. Another inflection point is also 0, 0, which is also IP, or inflection point. All right. And after this, well, even though I haven't asked this, but after this, well, if a problem asks you to make a graph of a function, make a graph of this function given, then as we see that we have found lots of points from this, right? We found the local minimum point. All right, we know this point, right? We found the inflection point, right? So we have like two, 3 points, right? So, and if you wish, you can also get more points, making x and f of x table. I think I showed this again yesterday video. So give some value of x, you'll get f of x. So that way you can get a graph. All right. So yeah, you can do that part on your own, right? Okay, let me do another one. Like I said, I'm doing 2 problems here. Okay, so let me do this one, the second example. So this example is basically from the book, but I see a few mistakes on the book, so I'm doing this here again, all right? There are a few mistakes in the book, yeah, so let me do this again. So, okay, again, I have to find the same thing, the whole thing I found here. Yeah, the whole thing. So, so first I have to find the critical number. So to find that, let me find f prime of x. So this will be 3 times 5 over 3 x to the power 5 over 3 minus 1, right? Using the power rule, minus the derivative of 20x is, well, we're just going to get 20. We still have this negative, so negative 20. So this is equals to, this is gone, right? So we just get positive 5 x to the power of 5 over 3 minus 1 is 2 over 3. And still have this negative 20, right? So this is the f prime, right? So now again, to find the critical number, I have to assume f prime of x is equals to 0. So f prime of x, we found this value here, or we found this equation here, right? So 5 x to the power 2 over 3 minus 20 is equals to 0. All right, so and from here, well, I can factor out 5, right? So if I do that, I get 2x to the power 2 over 3 minus 20 is equals to 0, right? And also here, this x to the power 2 over 3, I can also write this x to the power 1 over 3 to the power 2, right? You can write something like this, right? Minus, oops, this is, when I factor out 5, this is 4. So here 4 is also 2 square. And why I'm doing this, why I'm changing both of these to a square form? Well, there is a formula. Let's say if we have a square minus b square, if you take, if you subtract 2 square, then it will be a plus b times a minus b. All right, so this is algebra. So is equals to 0. So from here, well, this 5, well, you can just divide 5 on both sides, so you don't have to worry about 5. So this 5 will be gone. So now from these two, okay, like I said here, using this formula, I can say x to the power 1 over 3 minus 2 or plus 2, doesn't matter. And if I said this is plus, then another one will be x to the power 1 over 3 minus 2. is equals to 0, right? So from these two, now I can assume x over 3 plus 2 is equals to 0. Either this or this equals to 0, right? So from here now, I can move this to other side. So then it will be -2, and then take cube on both sides. So when I take cube on both sides, it will be something like this, right? So then, yeah, this 3 on the bottom and this 3 on the top will be gone. So on left hand side, we just have x is equals to -2 to the power of 3 is -8. And yeah, same thing, you got to do same thing here, but here you'll get with this, you'll get x is equals to +8. Okay. It's just that when you move this negative to the other side, it will be positive to here. We have -2, but this will be positive to another side. Okay, so now once we get these 2 points, well, again, we don't know if these 2 points are a critical number or not. Now, to find whether these two are critical number or not, we have to plug this in to the original equation and see if we get a number from there, some number, doesn't matter, whatever it is. In that case, we can say, okay, these two are critical number. You don't have to do that work. You can easily see, right? When I plug this in x to this equation, you'll get something, right? Doesn't matter, whatever it is. So, okay, this works. Again, with this, if you plug this in here, you will get something, right? So this works. So you can easily see. You don't have to show the work for this part. Now, so that means I can see these two are critical number. All right. And then now to find the increasing, decreasing, minus, plus, whatever it is, or local maximum, local minimum. So I have to find whether this reason is going to be positive or negative. So now if I take any point on this reason, let's say negative, I don't know if I say x is equals to -7, sorry, -9, sorry. On the left, it should be, yeah, -9, and plug this into this equation, this f prime equation, then you will get this reason negative. All right, you can check that out. And again, if you pick any point between here, if I say x is equals to 0, you can easily see that if x is equals to 0, then this is gone. So we just have negative number, right? -20. So again, this is also negative. And if I pick any point here on this side, let's say x is equals to 9, then you will get this side a positive number. Okay, so that means, well, negative, negative, we have the same sign here, but here we have a sign change. So it will be, on this side, it is decreasing, right? So decreasing, and from this point, it is increasing. So I can say that at this point, we have local minimum, right? So now to find this exact point, well, before that, well, I know this is negative, so this is decreasing, this is negative, this is decreasing, this is positive, this is increasing. So let's write this interval first. So the decreasing interval is from -∞ to -8, and -8 to +8. And the increasing interval is from 8 to +∞. Okay. And now to find the local minimum point, so I can say at this point, which is 8, so at x is equals to 8, to find exact point, I have to use the original equation here again. So f of 8 is equals to, plug this into this equation here, right? x to the power 5 over 3 minus 20 times 8. So you will get, when you put this in a calculator, you will get negative 64. So that means the local minimum point is 8 comma negative 64. So this is local minimum point. All right. So you have to specify that in the exam as well. So if you just write like this, I wouldn't know what you said here. What is this? So you have to say, okay, this point is a local minimum point. All right. And then, okay, we are done with the first derivative part. Now let's find the second derivative part, or whatever we need to find out using second derivative. Let's do that part now. Okay, so to get the second derivative, let's write the first derivative first, which is 5 x to the power 2 over 3 minus 20, right? Yeah, 5x to the power 2 over 3 minus 20, yeah. Now, after this, I can now take the second derivative. So the second derivative will be, okay, so it will be 5 times 2 over 3 times x to the power 2 over 3 minus 1. And the derivative of this is 0, so we don't have to write that. Right, so now from here, 5 times 2 over 3 will be 10 over 3. And x to the power, it will be negative 1 over 3, right? And if you move that to the bottom, it will be positive, so I can write this 10 over, if you move to the bottom, you can just multiply that with the 3, so 3 times x to the power positive 1 over 3. Right, okay, now now with this, now here it's not a polynomial, right? It's a fraction. All right, and this is f double prime. So now to find the partition point, well, in this case, again, if you go back to, I don't know, yesterday lecture, maybe, or maybe a day, maybe, yeah, day before that, or yeah, maybe Tuesday lecture. Well, I said that about the critical number, you can find the critical number assuming f prime of x is equals to 0, or where f prime of x is undefined, the x value, you need to find the x value where it will make f prime of x undefined. So the same thing with this f double prime as well. If you have a fraction like this. All right, so we need to find what value of x makes this f double prime undefined. And we can easily see that, okay, if x is 0, then we'll get this f double prime of 0 is equals to 10 to the power, 10 over, if denominator, well, if x is 0, then this whole thing on the denominator will be 0, right? So this will make this undefined, because any number divided by 0 is, this is 0. It looks like opposite 6. Whatever, yeah, this is 0. So anyway, this is undefined. Okay, so after this, now we can say, well, yeah, we can say this is a partition point, but still we don't know if this is the inflection point. All right, so now to find if this is inflection point or not, I need to make a sign chart, and then I can just plot this 0 here. Now again, after this, take any point on this region. Let's say any point, let's just pick x is equals to -1. All right, again, and plug this into this equation right here. So if x is -1, then put that in a calculator, and you will see that you'll get this negative. So you'll get this region negative. Again, pick any point on this region. Let's say x is equals to +1. Then you'll get this region positive. All right. So if this is negative, this is concave down or CD. If this is positive, this is concave up, right? So that means the concave down interval is from negative infinity to 0, from negative infinity to 0, and concave up is from 0 to positive infinity, right? And then we know at this point, so as we see the sign change here, right? So if there's a sign change, then this partition point in the middle will be the inflection point, or let me just write IP inflection point. But we need to find the exact point. So as we know that at x is equals to 0, we have inflection point. So now to find the exact point, I have to plug this into the original equation again. So when x is 0, the f of 0 is, when x is 0, the f of 0 is, well, this is 0, this is 0. So that means the whole equation will be 0. So the inflection point will be 0, 0. So this is the inflection point. All right. And again, if problem asks you to plot or make a graph or sketch a graph, then okay, I have a point here. This is also a point. Well, this is not a point, right? This is just the interval. These are not points, but we have a point here. We have a point here. So that means we have just 2 points. So we can find 2 or 3 more points. Again, making f of x table. Give some value of x, you'll get the value of f of x, right? And then you can just plot that. And this kind of graph, and you can sketch a graph, all right? So again, you can do that part on your own. But this is not the quiz that I'm asking you to submit. This is not part of that. So it looks like that's all I want to cover. So yeah. I'll see you on the next video. All right. Thank you.